After performing the analysis, let us go ahead to the very next tab, that is results. We have performed the eigenvalue analysis, so the first thing we need to do is check the vibration modes. So we can see the deflection or the different vibration mode shapes from here. Mode 1, I'll click on apply. So as you can see that the mode 1 is in X direction, X translation. Let us see this in the form of tables. So you'll go to the result tables and my vibration mode shape. I'll click on OK. Then here we can check the mass participation. As per the codes, we need to have at least 90% mass participation. So in the 8th mode itself, I'm getting 90% mass participation. We could have had less modes also, no problem. This is in the X direction. However, in the Y direction, I have got 90%, more than 90% of mass participation in the 16th mode. So that's there. And further, for the rotational in the about the Z-axis, I have received the 90% mass participation at the 8th mode itself. So here we go. We have successfully performed the eigenvalue analysis. Do not need to change it further. We'll go ahead with finding out the base shear of the response spectrum analysis now. So for that, we'll go to the results tables. There are various story tables available in MIDAS Gen as a result, out of which let us firstly see the story shear, the response spectrum for the response spectrum analysis performed. Here, I'll check on RS major, RS ortho, click on OK. And I'll go to check the story force coefficient. The ground level one, I need to know for the ortho as well as for the major. Now to get the stories together, I can use sorting tool for my tables. So I'll right click and say sorting dialog box, and I'll select the story, put it in the sort key column list, put it upwards, and click on sort and close. So as you can see over here at the lowermost ground floor level, my RS major and RS ortho values are there. Now I need to compare these values to the static seismic loads. Before that, I need to know if my response spectrums have been applied in the X and Y direction only, or is it some other angle? The major and the ortho angle I need to know. So for that, I'll close this command from the left tree menu. And here in the workstream menu, I'll just double click on the response spectrum major. As we can see, the excitation for the major angle is in the Y direction, and for the ortho, it is in the X direction, but negative. So similarly, we have got over here the values in the Y direction for RS major, and over here RS ortho is in the X direction. Shear force X, shear force Y. And their other counterparts are 0. So for finding out now the scale factor for modification of the response function, I need to simply select these values. I'll copy these values and paste it into Excel sheet. This is RS major and RS ortho. Paste it. I do not need this X and this Y value. So this is in the Y direction, this is in the X direction. Now I'll find out what is my static base shear. Static base shear for my X direction and for my Y direction. So I'll go back to the software now. I'll close this command over here, and I'll double click on the static seismic loads from the workstream menu. Go to seismic load profile, and here I have the story shear at the ground level, that is 6964.35, 7, that is in the X direction, and for the Y direction, I'll close this, cancel, double click here, seismic load profile, story shear, 6964.357, which is the same because the period is same, all the parameters were same, just the direction was different. And now I'm going to calculate the scale of factor. So for my RS major, the scale of factor will be static divided by dynamic. So 1.25, and this will be again for RS ortho, static upon dynamic, 1.75. So these are the two scale factors I have to use further for performing check of the story drifts, and also for creating the load combinations. So basically the story drift requires response modification factors. So firstly we have found out what is the scale factor. So I'll close this tables, and the next thing I'll do is go to the story tables under which I want to check the story drift. Here I'll select RS major only because response modification factor for major and ortho is different. So I'll click on OK. Here I'll check on response modification coefficient. I'll provide 1.25. Then here the scale of factor as per UBC 97 is supposed to be 0.7 into the modification into the response reduction factor, that is 4.5. And because we have seen that the period was more than 0.7 seconds, the allowable ratio to be considered is 0.02. I'll click on OK. And as you can see over here, the software has provided us a remark. If the story drift ratio is less than the allowable story drift ratio. Now this is going to be in Y direction, so we'll go to the drift Y. And this is not just a table. Out of this table we can create graphs. So for that I'm going to select the stories. I'll select the allowable story drift ratio, and I'll select the story drift ratio that I have found. I'll right click and say show graph, say OK, and as you can see over here, the software has provided us with a graph. This is a story drift graph, and we can, from here we can understand if we can further reduce the size of the columns and make it more economical, make the structure more economical. So this is the story drift check result. Similarly, we can go ahead and check the stability coefficient. We can check for the irregularity of the structure. Then we have soft story check, weak story check. Then also we get the story shear force ratio. So all these are available in the software, which provides you with the remark if it's okay or not, depending on the allowable limit. This entire table can be copied and pasted into Excel sheet. I'll close this table now. So here we understand that our entire analysis is perfectly fine, and we can go ahead to check the rest of the analysis results. So let me start with the reactions, reaction forces moments. Now here I need to create load combinations. So for load combinations, the first thing I do is go to the load combinations tab, load combinations tool, and here I can in the general automatically generate as per the code for concrete. This is the add envelope. Here I've checked it on to check the envelope, and I've selected the code, concrete code. Then the design code for concrete I'm selecting as ACI 31814. Here I need to provide the scale up factor for my RS major and RS ortho. So it's 0.25 for RS major, I add it, and 0.75 for RS ortho, added. Further, I can also consider the orthogonal effect by checking this on. I'll click on set load cases for orthogonal effect, wherein I choose RS major and RS ortho and click on add. So the software makes two load combinations over here, in which 100% major and 30% ortho is added in the first combination, and in the second it's 100% ortho and 30% of major that has been applied. So I'll click on OK. Then further I can just check on this, click back on this minus sign to see this OK option over here, and I'll click on OK. As you can see over here, the software has automatically created all these load combinations as per ACI 318. And at the end, there are two envelopes, envelope for strength as well as for serviceability, considering all the serviceability and the strength load combinations. Now, when it comes to analysis results checking, I want to see only the envelopes. So for that, I can inactivate all these above load combinations. For that, I'll go to the spreadsheet form and I'll change this active to inactive. I'll copy this inactive and paste it to all these cells just like we do in Excel sheet. Similarly, I'll go to the concrete design tab. For performing the design, I need to create separate load combinations over here, which can also be automatically taken care by the software. So I'll click on auto generation. Already I have concrete here by default, and the design code I have to select is ACI 31814. The scale up factors are taken just like we had done for the general, so it's already there. I have to just check on the consider orthogonal effect. Here also it's already done, so I'll just click on OK, already defined, and I'll click on OK. So as you can see, the strength as well as the serviceability load combinations have been created. Out of these load combinations, the software will design for the maximum load combination, design for the strength, and check for the serviceability. I'll close this dialog box now, and then we'll go ahead to the reactions. So here we can see the maximum for the load envelope, strength load envelope, maximum value. Here there are different components, so let me see the vertical reaction, that is FZ. These are two horizontal, so this is vertical. I'll check the FZ. I'll see the value onto the screen, so I've checked on the values for the type of display and click on apply. So as you can see over here, all the reactions have been displayed onto the screen. I can get these reactions in the form of tables as well. For going quickly to the tables, all I have to do is click on this small box over here. Select the load combination. I want to select envelope strength and maximum value only. The software also allows you to select from only those nodes for which you are interested. So you can click on OK. As you can see over here, this is the entire table, and the summation of all the forces is also shown over here, which matches with the base shear, the static base shear that we had seen. So let's do right click and sort this entire dialog box like we did earlier for the story drift, and let's sort this dialog box for checking the maximum vertical reaction. So I've checked on FZ over here, put it on the sorting key column box and put it up. I want to see the maximum value at the top, so I uncheck over here the ascending and I'll click on sort and close this dialog box. So here you go, you can see the maximum reaction, vertical reaction is 23,134.64 kilonewton, and it is found at the node number 22. This entire table can be copied Just click over here, the entire table will get selected. Copy this and paste it into your Excel sheet. Or you can just simply right click and say export to Excel. So a new Excel sheet will be generated automatically at the location where you have saved this file. I'll save it again. Okay, let us get back to the model now. Isometric view, and check the deformed shape of this entire structure. So I'll go to deformations and say displacement contour. This I want to check for the serviceability load combination envelope. So I'll click on this and I'll say no values but deformed shape, and I want to see the legend. I'll click on apply. So this is the deformation and the maximum is, I'll just pull this down to see it. It's 124.5 0.31 mm. I can at any point of time change the units to see my result value. So I'm just changing it to mm. Okay, so as you can see over here, it's 124.31. Again over here I can make it fixed by going to the legends options right over here and make it fixed value. Click on OK. Yeah, so it's much more clear now. It's 124.31. This value can be displayed onto the screen as well, the maximum value, by clicking over here for the values and clicking on the minimum maximum only and click on OK. Okay, so in this way we can get to know which nodes are having maximum deformed shape, maximum deformation. This entire deformation can be animated. For that I'll check on animate over here and I'll click on apply. I'll say record. This entire animation will get recorded and it can be saved as per as .avi file format, which you can use it for your presentations. Just click on the save and .avi file format will be saved. I'll click over here to close this animation. And further, for any of my reports, like I just did the animation for my presentation, I can take the picture of this particular deformed shape to my report. For that, I do not have to say print screen, or I do not have to go for snapshot or click. No need of that. I'll just right click and say dynamic report image. I'll click on OK. And this report image, I'll close this dialog, can be seen over here in the report tree menu. So you can see this deformed contour. Okay, I can as well see the initial view. Right click over here and see dynamic report image and click on OK. So as you can see over here, these two images have been created by just right click and dynamic report image. Okay, after seeing the result for reaction table, again this reaction table can be taken as a dynamic report table. Now it's a pen support, so I do not need the moments. I'll uncheck these columns and I'll click on OK. So here under the user defined tables, reaction table has also been added. Moving on further, let's see the beam diagrams. So we'll go to the forces and beam diagrams. I'll select the maximum strength envelope, or I can go for, I'll select the first load combination. This is the component, so I'm selecting MY over here, moment about the major axis. Type of display, display options are there, so I'll have a solid fill for a better view. Make it contoured, and I want to see all the values, so I'll click. So yeah, minimum maximum only is checked off already, so let this values be checked on. I do not want deformed shape, no legend as such. I want to see all the values onto the section. And then I want to see this particular beam diagram for some of the beams. But before that, let me tell you that we can see all the beam diagrams at once. So I click on apply. So you can see all the values, all the beam diagrams at once onto the screen. So if I want to see only particular beam or number of beams, then all I have to do is select them and click over here at the active by clicking over here in the front view. So this is in kilonewton mm. I need to change it to kilonewton meter. So as you can see over here, these are the values for my bending moment diagram, and this is the diagram basically of all these beams. Now I can take the image of this beam diagram by again right clicking and dynamic report image. I'll click on OK. So my beam forces moments diagrams can be taken in this way. Now let me check the wall diagrams. The basic advantage of having a wall type of element was, as discussed earlier, no need to mesh it, no need of dummy elements, no need to divide it, no need to take the plate cutting diagram for finding out the forces at the top and bottom of the wall for further designing it. So let me activate the entire structure. I'll first have the initial view and I'll activate the entire structure here. Okay. Now I'll go to the forces again and click on wall diagrams. Again, I'll select over here the maximum strength envelope. This is the moment about Y. I want to see what is the actual force. So I'll check on the Fx value. X is actual in-plane axis of one of the in-plane axis of the shear wall. And then I'll click on apply. Okay, so as you can see over here, the Fx value goes on decreasing as we go up. Fz value, the shear force value, and the My component as well. Oh, and let me just activate only few beam walls and show you this is the way in which we can get the values for the design purpose. I can take a dynamic report of this image too. Okay, now that we have checked all the results, we can report this entire results in a very useful feature for reporting in MIDAS Gen is the dynamic report generator. So I'll click over here and you can open up a new file or an already generated report. So I'll click on new document here. This document is a Word document. So anything you can write by yourself, the project information, the title, anything. Then I'll close this command. I'll be in the report tree menu. I'll just click on here. This image is in mm. Deformation is in mm, so it's all given in the brackets. So here I'll just change my unit system and I'll drag and drop this image over here. This is my original image over here of my model. Then the deformed contour. Deformed contour is also having the legend and the values. So everything is there. Then the beam diagram. Now, what I mean to say is the beam diagram was taken in meters, but right now I have got over here the unit system as kilonewton mm. So I can just drag and drop it over here. If I do so, then the values displayed over here is in kilonewton mm. Then I'll also drag and drop the wall diagram over here. Then I've got the reaction table, so I'll drag and drop the reaction table. And this is how my entire report will get generated. So once this report is generated, later on it often happens that the architect makes some changes to the model. Or there are some structural changes also required. Maybe a column or two must be added or deleted. So the entire model gets revised. So I'll just activate the entire structure. I'll take you to the initial view. Here I'll make some very significant change. Let me delete some part of the structure itself. I'll say delete. Okay, so as you can see, this part of the structure is gone, and I'll perform the analysis again. I'll be performing the analysis, and then I'll be checking the analysis results, and then after everything is fine, I will have to go back to the tools, and then again the report should be generated, right? This is how generally people have to do. In other softwares, it provides you the entire report of each and every element, of each and every node, reaction, if each and every image, which you have to take again. Out of those, a few are supposed to be taken and a report has to be generated. This entire work is too hectic when it comes to regenerating the entire report. In MIDAS Gen, the dynamic report generator can automatically take all these changes into consideration. So I am selecting all of the images and the tables and charts, text, image files, any, and all I have to do is click on regenerate. So what the software does is it will just make changes to those images, to those reactions at those similar places where you had kept them in your entire report. So you do not have to go through this entire report again and then make changes. So there is no issue. These are not images. You can highlight them. You can change the fonts. As you can see, there are changes in the model, in the report, automatically generated by the software. So this is about the dynamic report generation by MIDAS Gen. I'll close this dialog box, which can be saved. I'll go to the initial view and I'll activate the entire structure. Okay, and I'll undo it. Yes. And I'll rerun the analysis now.